Hi guys, welcome back to my channel. In today's video, we will work with Azure Search Service. We will implement Azure Search with RAG. I'm sure you guys have seen so many videos on RAG, but in this video, we will try to do something very different. But before that, let's have a quick demo and then we'll work out what we are going to implement in this video. The first thing is in Azure Search Service, you have data sources. So I have created Azure Blob Storage, which contains my files, my storage files. I have generated 100 JSON files, and these files are related to insurance policies. If you look at the individual file, this JSON file has these properties. It has ID and content. The content is actually the whole content of the insurance policy, insurer, title, tags, and the amount. And then we have is active flag, and then we have content vector. I will explain this content vector in a detail in a few minutes. And I have created an index, and this indexer takes information from the data source and inject into the index. So if I look at my index, it has 100 files, and each and every file matches that pattern. We will create this search application, and we can perform search here. Then we will use .NET API and create a function app and perform the search here as well. So this will be more detailed search. So we will work on the keyword search query and the vector search query and try to find out the difference between them. And then we have different filters and facets. So what is size, what is facets, the columns you want to display, and what sorts of filter you can apply, and what is order by clause. So this is all simple Azure search with RAG. I'm sure you have seen so many videos on this. But we will try to do something different. What we will do is we will create an MCP server and expose this search as an MCP tool. So I have created a web app and exposed my MCP server into this web app. And I can test this with my MCP Inspector tool. I have this tool created, get search result, and this asks me a couple of parameters. For example, the query. I can apply for the filter. I can also specify order by clause. So when I run this tool, I get this data back. So this is happening in that MCP server. You can create an agent through Azure AI Foundry, or you can install a VS Code extension and create agent from here. So when I created an agent, I can specify the name of the agent, the model I want to use, and the most importantly, the instructions this agent need to follow. And then we have integrated that MCP server into that. So once it is all integrated, then we can write a prompt and we can display the search result. So this will be a detailed session. So let's get started. We already have a function app which we have been using in the last couple of videos. Go to triggers and create a new HTTP trigger. So we call it Azure Search. So that will be HTTP trigger. We will use this trigger to test the search results. But to upload documents, we need to create another trigger. Let's call it Azure Search Documents Uploader. So that would be HTTP trigger. Okay. Now let's create a service which will upload the document. So you go to class library. If you don't have, just create this one. Sorry, not this one, the class library. In the services, we can use this service, storage account service, or you can create a new one. I can create a new one. Let's call it document service. And now create a class which will define what type of documents we want to upload. I call it Azure Search document. In this class, we will define all the properties of that document. For example, we can have an ID field, and this is not a searchable, so we can just add a simple field. We need to install a package. Search for Azure dot search dot document. Install this package. And this is our ID field. That would be is key is equal to true. Now we can create another property which is content, which is the actual content of the file. And this is a searchable field. And analyzer name would be, so that will be lexical analyzer name dot values dot en lucene. So en mean English and the lucene is the technology. En lucene. Then we can have insurer. That is also a searchable field. So we just copy that part and put it here. So every policy should have a title. So we can have a title field. That we can make it just simple field. Then we can have a string array of tags. That we can make a simple field, but we can use this field to filter. So is filtered true and is facetable true as well. That's fine. Then insurance usually have amount, so we can have a double field called premium amount. So that will be simple field, but we can filter and sort as well. Then we can have a Boolean field which says this policy is active or not. And we can provide filtering as well on this field. Now, at last, we need a vector content vector field, which we will use in a search. And I will explain in detail when we get there. So just create a property that will be a float array. That will be content vector. This could be a simple field, but we don't want to filter, we don't want to sort, and we don't want to facetable. You don't want to, okay? And then we need to provide some vector configuration. That would be vector search field dimension is equal to 1536, and then we need to provide a profile name. That would be vector search dimension, and then profile name, just any name, vector profile. Okay, so that looks fine now. Now in the document service, create a method that says, let's create a constructor first. Create a method that will return the list of the documents. That will be generate health insurance documents. Okay, so one option for us is to have a list and then hard code these values, which will work. But we want to generate more than 100 documents or approximately 100 documents. If you do this way, that will take a lot of time. There is a library that's called Bogus. We can use that library and generate this document. Just search for Bogus. Quite famous library is 136 million downloads. Now let's define what source of coverage this insurance policy have. And that would be hospitalization. Another option could be prescription drug, dental, could be something related to vision, preventive care, mental health, maternity. Normally, insurance policies have some exclusions, so let's define an array for exclusions. Cosmetic procedures, then experimental treatments, or we can have some therapies, alternative therapies. Now, insurance policies also have extras. So let's create an array for extras, which we can call extras. So the dental is normally comes in extras. Vision plan, wellness program. Now let's create some fake documents. And the type would be document, the file we created, Azure Search document. And then we define different rules. For example, for the first field is ID. So what we want to do for ID would be that should be a grid, I think. Let's create. That would be a properties like this. So that is for the title. And now let's copy this. And for the title, we can say we can write a text policy and then we can append ID in it. So this will become policy and whatever the ID of the policy is. Insurer, we can use the company name and then we can and we don't want to hard code. So what we can do is we can pick a random. We have defined coverage types, so it will pick a random coverage type. Okay, for the premium amount, so that would be finance. Finance dot amount and maybe between 500 to 2500. And this needs to be converted into double. Is active, we can just pick a random bool. And then we need one for the content. So this policy covers, there will be random. We have coverage types, and then in the next line, optional extras include, we have the extras, that's fine. Then we can add exclusions. It will pick a random exclusion or not covered. And then we can have who is providing the insurance. So whatever the company name is, and then we have insurance. So that would become the company name. Okay, so we are done with the sentences, and then we just need to return. So we can order by these sentences. So there'll be random dot in. So it will randomly pick and arrange these sentences. So we don't have to hard code 60 here. Okay, let's register document service. You go to your function app, and in the program, services dot add singleton. Service. And now we need to call it from the function app. That would be document service, generate documents, and let's say just for the testing, we say we want to generate 2 documents. Endpoints. So we got 2 documents generated, and content vector is null, which is fine. And we got some content generated, ID, integer, active, and the tags. Yes, it looks fine. Okay, so then we can just return these documents. Okay, so once we have these documents ready, we need to upload them into storage account. We can create a new function here which will accept these documents and upload them. We need to create a blob client first. Go to storage account, and I think this is the storage account we have been using. Create a new container called rag document, copy the name, and that's it. Okay, so we need to have a container client. Install this package. Okay, so this needs a connection string and the blob container name. So we can pass this connection string here. We can define a connection string. So that will come here. So we don't have to pass it in the parameters. And second thing we need is the container name, which we have just created. Okay. Now let's work on how to get this connection string. So you go to your container, In that security, go to access keys and copy this connection string. And this contains sensitive information. So I will be writing in user secrets. I already have this Azure Web Storage which contain the connection strings, so I can use this one. So only thing I need to do is go to I configuration, install this package. Yeah. So we got the connection string. And one important thing, because I added this connection string in a user secret, so in program files, you need to add this line. If you don't add this line, you won't be able to read from the user secret. So that line is important. Okay, so we got this connection string and we got this blob container client. Now just add a for each loop for the documents. So that would be the name of the files, which is the ID, which is random UUID GUID. So that will become the blob file name. And then we are just serializing it. And we can pass an optional parameter, which is, and I think that's it. Let's run it and test it. So now when we call this function, we will pass documents. I think we need to call it first in the function app, in the triggers, document uploader. Once we get these documents, so this we need to await. You can make this async. And the second document also uploaded. Let's have a look. Okay, looks like we have uploaded the document. Just download and verify. So we have ID, we have content, insurer, title, tags, premium amount is active, and content vector is null. I think it's not spelled correctly and it's null. So now let's work on this part. Okay, so this property is for the vector search. So vector search mean if you try to search with a keyword which does not exist. For example, if I'm searching for a hospital and if I misspell it, the search will not return any result. But if we do the search with the content vector, and even if I misspell it, it will still return the result. So it will not match the exact keywords, it will match the close keywords. But for this to work, we need to have an embedding. So we need to create a embedding first. So go to Azure AI Foundry. If you notice the type of this content vector is float array, which is not a string. So what we need to do is whatever user type, we need to convert into this float array and then store in the text file. So whenever we make a search, we will use the same embedding, and that embedding will automatically convert into float number and then it perform the search. So we need to create an embedding model first. So go to model catalog. You can see a big list of models here. So we have to filter out, go to inference task and search for embedding. So these are the embedding models available. I have used this one before. So let's pick this one and click on use this model. Choose this option. This is a deployment name. You can change it if you want. I'm okay with global standard and just deploy it. Okay, so the deployment has been created. So just copy this name and go here and create a function. So that returns the float array. And we can name this function get embeddings. So this will take a text. Now, before that, so now we need to have an embedding line. Let's install a package. The package name is Azure.ai.openai. This one is a stable package, so we can install this one. And this need a key, so that would be Azure key credentials. So we'll pass a key here. Then we have this client option, and this need an endpoint. And then we'll provide some sort of URL here. First, now let's find out what is the key credentials. So you go to Azure AI Foundry. You can copy key here. So I will save that key in user secrets. And then we need to have this URL. So we go to overview, and there is an Azure OpenAPI. Just copy this URL. I think I already have that. Yeah, same one. So we can use this one. Just remove the slash at the end, and I can call it maybe OpenAPI. Okay, one minor change we need to do here is, so in that URL, so once it retrieves the configuration, we need to append slash models at the end. That is the URL of that model we have just created. Okay, so we go to the client. The next thing we need to do is embedding client. And this need the model name. This is our model name, so just copy that name. Okay, and then in search, and then in here, embedding client dot generate embedding, and just that takes the text, and then simply return it. That will be response dot value to floats, not to array. So that returns an array of floats. And when we are uploading this document, just before uploading, so document dot content vector, we call get embedding, and we pass the whole content of the file. So when we are uploading this document, for each document, we pass the content of the file to this get embedding, and this will take the text and convert into the float array and return that into this property, and that will be uploaded. And I think let's test it. He can delete existing files. So it is passing this text, float 1536 something. So it would be something like this. And that will be used to upload it. Okay, let's refresh this and download one file. Which one is the latest one? Okay, so we got some numbers which is called content vectors. Okay, so that looks fine now. So what is the next? We have uploaded only two documents, so I can change that to 100. But before that, I can go ahead and delete the two and just run the function, and that should upload 100 documents. It take few seconds, I guess. So that's done. And just to refresh it, and we got almost 100 documents. Okay, so that's all good. We need to create an Azure AI Search instance. Click on Create New Service. Pick your region. So there are different options available, pricing tiers. So I can go ahead with the free one, but make sure when you use into production, you have to choose standard or above. The free one will be slow, but it's okay for our demo. Just create. Okay, the search instance has been created. We need to work on three options. Let's start the data source first. Add new data source. We already have that blob storage, and just pick a name. Click on create. Okay, so the data sources has been created. So we created one data source. Now for the indexer and the index, we can use .NET code and create these two. So let's go back to your function. So we have done this. So I can comment out this one, these both. And in that service we created, document service, I can create one function, create or update index. That will be search index, and just type a name of the index. So that would be insurance documents. This needs field, and this we need to provide file name. So the file we created is Azure Search document. It will automatically go into this file and fetch all the field and create the same fields in the index. And because we will be providing the vector search, so we need to configure the vector search. That will be a vector search profile. The HNSW algorithm configuration. We need to create a search client. This needs search endpoint. Copy this URL. So that will become Azure Search endpoint. And then we need client credentials. We need to provide the key. That is confidential. So we need to go in user secrets and take that value from settings, keys, copy primary key, and paste it here. So that would be create or update index. The breakpoint and just run it. Okay. So this now should create an index. Okay. So it has created index, but it has zero documents. Next thing we need to do is we need to create the indexer. Look, let's go back to the same function. Create a new function. Create a new function. Create or update indexer. The name could be insurance documents indexer, I think. Data source. Let's copy the name of the data source. Then we need the index name. That's the index name. Parameters. Configuration. Because we have stored because we have stored documents in the form of JSON, so that will be parsing mode is JSON. Then we have field mappings. So the field we have is ID, I think. Yeah. So this ID and the target field name is equals to IDs. Both have same field name. So we have to define mapping for all these fields. So if you look at the indexes, if you look at the index, so we have these fields. So that's why we are defining this mapping. Okay, so we are done with the field mapping. So with the indexer client, node create or update indexer. And that needs an indexer. And I think that's it. That update the main function app. We are done with the index. Next thing we need to do is create or update indexer. Okay, no error. So it should now create an indexer. Yeah, we can see. And it says it has loaded 100 documents. So we can run it in a schedule. If you keep updating your data source and if you want to rerun it, you can run from here or you can reset. If there is a change in the data source, you can reset. And our index says that we have 100 documents. And if you don't type anything, you can search. It will show you all document, everything included. And if I, let's say, search for hospital or for this 14 document, and if I search for something, dental plan, I go 72 documents. So this will search dental or plan. So if I double quote it, then it search for exact word. So there are 36 documents containing exact dental plan. Okay, so that's one way of testing it, but we will be using .NET API and we will call this Azure Search service from .NET and perform multiple operations. So it's just testing and there will be a filtering and there will be sorting and a lot of stuff. And then we will also work with vector search and then we try to understand the difference between the keyword search and the vector search. So let's move to the function app. So the trigger we created was this one, Azure Search HTTP trigger. So we will use that and call the API, call the search API. So I can remove this post. That will be request data. So that returns a response. And then we can response dot void as JSON string. That's a test message. So this is not return. Okay. So that's it. So this is our trigger now. I can leave this open or maybe just create a new. Okay, so that trigger is working. Okay, so the first parameter we'll pass would be the keyword search. And then we need to create a method which will actually perform the search. So we can do in document service. Create a method here which is public async. So that would be a task. We don't know the type yet, so let's leave it. Search document. So that will receive a query. So the search result will be if we create a search client. No. So first thing we need to do is we need to create a search client. So that will be a search client and it needs search endpoint, the name of the index, and this key credential. So looks fine. And in here, not first async, and that should receive a query. And it will return a type search document. Okay. So the return type would be task of response of search results. Task of response of search results of search document. Okay. And then we can return this search result. Will be await. And I think that's it. Okay, now we need to call this from the function app. So we need to get, we can copy from the other function. We get the document service. So we have search document and then we pass this string query. So this will return search result. And let's see what it returns. In the keyword query, I am passing hospital. Okay, it returned us a response. Okay, in content, we can see the results. Okay, so what we can do is we don't have to write this message now. So that would return the pages or the documents. So search result dot value dot get results async. And then we can write this. Let's run it. Okay, so it returned me a score and highlights and few other things. It returned me a document, which is what we need, but it did not return me accounts, everything else, count or anything else. So what we can do is we can change this response to write something. Let's say total hits, and then we can say return total. So that would be the documents dot count. And finally, we display the results. So whatever in the documents, we just displayed here. Okay, let's see the output now. Okay, it returned 14 results, but the total hits is coming as null. You need to fix that. And in result, you're getting some information back. So that looks fine. We need to fix the total hits. The total hits is basically coming as null. So what we need to do is when we perform this search, we need to have a search option here. And it says include total count. So we pass this option as a parameter. That will be used here. And then we pass it here. Okay. So the total hit was 14 and it returned us 14 results. And then we have results collection. The score is this. We will talk about heights in a few minutes. And we don't need these things nulls. If they are coming null, we can just hide them. And then we have this document, which is our file, which has ID, which is fine. Content is the content of the file, insurer, title, tag, amount, active, and we don't need this for the time being. So first thing, let's remove these nulls. So removing null is pretty easy. We can have a JSON serializer option here. So we need to change this to string first, and then we can have, so that would be JSON serializer dot serialize. Okay, it's returning as a string. We just need to add one more parameter. That will be response dot header dot add application JSON. Okay. So the nulls have been removed and now the total hits is 14. If I search for dental, it is 36 and looks all okay. Now, the next thing what we can do is we don't need to display this content vector. So let's first remove this part. So in the options, in the search option, we have a property called select, and there we can define the fields we want to return. So what we can do is we can get this from the query string, let's say columns. And if column is not null, then we split them by comma, and I think that's it. Intelligent. So let's say I just need ID. Okay, we go to ID only. So let's say we need ID, we need content, we need title, and we need insurer, tags, and then premium amount. So we need these fields. We also need is active, and now it should return only these fields. All good. Now let's talk about some filtering. For example, I want to filter all the insurance policies where is active is true. So what I can do is I will define a filter which says this equals to true. and then we have to define a filter here. So that will be a filter. So in that option, we have a filter, and whatever filter we define in the query, it will come here. So now I said is active is true. So the filter is being applied. This one is active equal to true. And now return 16 items, and all of them should be true. Yes, they all are true. And if I say false, so now we go 20 and all of them are false. Now let's say we want to filter out that it should only return where premium amount is greater than 1500. So that would be and premium amount greater than is GT, and that would be 1500. So currently return 20 documents, and let's see. Yeah, it should reduce. Okay, now it returns only 6, and all of them are above than 1500. Okay, all good. So what is the next filter we can do? The tags. Because tags is an array, so the way it works is, so we can put an and or. That will be a tags slash any tag equals to, let's say I want hospitalization only, and the single quotes closed, and okay, so in the tags we have hospitalization and we also have hospitalization here. So it returned only 2 documents. But if we say don't want this, only this flag, this filter, then it returned 4 documents. And if we say remove this as well, just tag, then we got these 9 documents. Okay, so I'm putting all those filters back. So this is how the filter works. Now, if you notice that we can also sort them by premium amount. For example, this is 1600 and this one is 2120 and this one again 1196. So we can sort them on premium amount. So that I will call sort, or maybe order by, or maybe sort. So I would say premium amount. So sort by premium amount. So I copy that and go to the function, and we copy the same thing, change that to sort. So there is a property called order by, which is a list of string. That means it can take multiple as well. Okay, now let's run and see the result. So I'm just saying premium amount and it would sort by ascending order. So 1600 and then 1900. So let's remove this filter. So 537, 542, 720, and 752. Okay, and if we say sort by descending order, so the most expensive comes on top and then the other one, and then less and less and less. Okay, so we have done the sorting as well. Okay, next we can work on facets, which is also very useful when you're creating a UI. For example, I want to return how many are the prescription drugs. So we want to count them so we can display in the UI. So that is called in facets. So that will be on tags. So I want to count and I want five of them. So we need to go and change the code. So it works same way. So copy that. So there is a property called facet and it takes list of string and we can specify that. Okay, let's run. So I said apply facets on tags and return the top five. I can't see it. Okay, so we have been doing a mistake here. So that filter needs to come here. Sort will go here. And the facets will come here. Okay, so in the search results, we have value and that has facets and then had tags and then it has further keys and values. Not a problem. So what we can do is just before the results, we can display facets here. So that will be search result dot value dot facet. If it contains something, if it is not null, then select many. So that will be x dot value and that will be a dictionary. And there will be y. So we can display in a key value. So the key would be y dot value and then we can display how many are there. So the count would be y dot count. Okay, so the vision has 15 documents, mental health has 14, and then we have sleep. So we asked for 5 and it is returning 5. We can display only 2 as well. Okay, so that's looking good. Now we have searched for the keyword search query only. So for example, if I misspell it, I say dental 1, what happens? It returns me nothing. And if I make this E, misspell it, it returns us nothing. So that's a problem. So we must type it exactly, otherwise we won't get anything. And let's say if it is dental, and if I say E, it returns us nothing. So the problem with the keyword search query is you must type it exactly. You can't misspell it. You can't use other similar words. So that's why the vector search is. Let's put vector search in. So we have keyword search query. So we can now have vector search query. If it is null or not null or empty, then we define a vector query, vectorized query. So that needs a float, which we can pass in a minute. So that needs a float because, as I said earlier, the way vector search works is you can type this sentence, for example, optional extra. It will take that word and convert into these float numbers and store it with the document. If you want to search it, you have to convert this into numbers again and then pass it to the search API and it will match with these numbers. So what we have in that document service we created, so we have a function called embedding, which takes the text and returns the float array. So we can use it here. So that was document service. What was the name? Underscore document service. Get embeddings. And then we pass this vector search query. So it will return all the numbers. And then we have field, which is, what is the name of the field we have? It's called content vector. And I think that's it. We pass this. Now in that search option, vector search equal to new query is equal to the vector query we had. Okay, let's put a debugger and run it. So we need to add a column, a new field, vector search query, and we can hopefully drag and drop. So we're not using keyword search, and this time we will be searching vector search. So the text we are passing is hospital and it returns an array. Yeah, it returns these values, which is what we need. So then it is assigned to the vector search, and I don't think we need to do anything else. Keyword search would be null. Maybe we might need to change that. Let's see. Okay. So we can remove these facets so we can see it clearly. Let's search for hospital 1. Yes, it returned me same result, which is okay. If I misspell it, it still returned me same results, which is what we are expecting. And if I type teeth, it should match all the dental results. Yeah, maybe we can write teeth surgery or maybe heart surgery. Yeah, it does change results, and we can see updates. Okay, so we are searching with vector search, but every time we search, it returns a lot of results. So it's returning 50, which is the default size. So when you do the vector search, we can specify how many similar results we want to return. There is a property called a nearest neighbors count that you can set to maybe 20, 30, or depending on your need. So let's say if I set for 20, so this will search all the results, all the similar results, and return us total 20 results. So it will find out all the similar results and return us only 20, first 20. Let's see the effect. So for example, if I'm searching for hospital, okay, so the hospital may not even exist in this content, but similar results will be displayed. And then on top of that, we can apply filter and reduce the number of results. Okay, now let's talk about the size property. So by default, the 50 is the size. So this is a number of results you want to retrieve. So if size exists in the query, then use size, otherwise use 50, which is the default value. So let's say we are searching with vector query and the search term is hospital and the size I want to give, let's say 10 results. Okay. So it says that the backend API returned us 20 results, but then we filter out only 10 results. That's why the size property is. Okay, so you got an idea of all the different search terms. We we worked on the vector search, we worked on the keyword search, then we have these columns, what columns you want to display, then we have huge list of filters. You can apply filter and narrow down the results. Then we have sorting, facets, and size. This is all working fine with Postman. How would we integrate this with large language models? How do we integrate this with a Copilot or other agent? That is why we have MCP servers. We will create an MCP server and we will define a tool. So that tool will connect to this .NET API and return the results. And then we integrate that MCP server into a Copilot agent. So we can create multiple agents. So one option for us is to go to Azure AI Foundry and create an agent here, or we can use Real Studio Code and we'll use an extension. But before that, let's create the MCP server first. Okay, in previous demo, we had this weather alert tool. We will leave it there. We are not making any change in that. And if you are new to this video, you need to install a package, which is this one. And this is a preview version so far. So make sure you install this package and you need to add this line that will run the MCP server. So let's create a new tool here. Create a class and we call it Azure Search Tool, because there could be multiple tools. So we can maybe Azure Search Tools, I think. Create a new function here. Create a new tool here, in fact. Now, the most important part for the tool is to define what this tool does. So that is MCP server tool. And then we had to type the description. So the first parameter is the search query, which is string. And we're just returning a null here. We have to specify what type of filter it would be and what sorts of value it contains. So this is an optional field, and the format of that would be OData. So this will be optional OData filtered expression to limit results. And then we can give an example. We copy that example from Postman. So this will be our example. Sort by field is also optional. We can give an example. Okay, so that is enough for the description of three parameters. One option for me is to write it, or second option, or the better option is to get ChatGPT or DeepSeek to generate it for us. Let me give it a context. I got three parameters, so just copy everything and paste it here. I think this one is better. So let's copy that and okay, now in the implementation, let's have a look at that function app. The function app we had is this one. So this all we need a document service and then it pass the query and the option. So copy the document service section. That can go here. And it needs an option. So we have specified option here. Okay, so when we were testing with Postman, we had this columns option, but now we know that we always need these columns only. So we can just, when we specify the search options, we can say select is equals to. And if this filter is not null, that means filter is provided. So then option dot filter is equals to whatever the filter is given. And similarly, if order by not null or empty, then order by is whatever the order by is passed. Now it's a list. So we need to add order by. Okay. And the last thing we need to do is the document service dot search document. The query text is stored in a query variable, and then we have this option. Okay. And then we call this function get result, which will actually return the results. And I think that's it. Now we have to run this and test it. So make sure set as start a project and run it. So how do we test this MCP server is you go to MCP Inspector, copy this part, open a command prompt, just paste it here. So when the web app is running, there will be two URLs. So make sure you copy this one, which is HTTP without HTTPS. So copy that. Is it doing anything? Okay, something is not right. Okay, so we need to add the tool we created. So that tool name is Web Azure Search. Because this will be using the document service, which is we added here. So we need to add as a dependency. We can copy from function app, just copy that line. copy this URL and probably just rerun it. Okay. So make sure you select Streamable HTTP and you paste your URL here. Make sure it ends with a slash, and then you simply click on connect. And when you connect, you will see something logged here. Click on list tools and it shows the tool we have created. So as I said earlier, the description is the most important thing when we deploy this tool to the large language model. This tool will be triggered based on the description. So you can put as much as you want in description, and this should clearly explain what your tool is. So let me search for something. Okay, so we have to provide the keys. So copy both and same for the user secret. I'm putting a breakpoint here, and we go back here and simply just click on run. Session timeout. So probably we need to disconnect, connect, and try this thing again. Azure Web Job Storage. Probably we don't need, so we don't need to worry. I did not copy this. Search endpoint and search key is there. That's what we need. So that looks fine to me. So the search query we typed is this hospital and whatever the default option was. So I think we didn't define any filter and we did not define any order by. The only thing we defined is the search query. So let's see, it should return something. Okay, it shows success and we got search results back. Great. So let's apply a filter here, which possibly, let's say this one. We only getting is active is equals to false, and it should return only false is active false document. Looking good. So let's look who is active true. Okay, so now we are done with the testing with this MCP server tool, and we have tested only locally. So the next thing from here is to deploy to an Azure AI Foundry agent. So there are two ways to create an agent. One option is you go to Azure AI Foundry, click on agents, and click a new agent from here. Or the second option is you go to VS Code and install this package or plugin or extension, which is called Azure AI Foundry. And this will give you an option to create an agent here as well. So I will choose this option. I click on this plus sign and it opens a new window for me to create an agent. I will say Azure AI Search agent. We can pick a model. I will pick this mini. And as I said earlier, this is the most important part of the agent, defining the description or instructions. We'll do that in a minute. And then we have this option for specifying the tool. There are different ways to provide tools. So we will be doing this MCP server. So click on that. So this needs a URL. So URL means we have to deploy this first, deploy to Azure, and then we can use the URL. Okay, it has been published successfully. Now let's open the web app. So we need to make sure that we have added all the configuration things. So we have Azure OpenAI endpoint. That does not exist. Find it now. So copy this and paste it here. Then we have Azure AI Search endpoint. We already have that, and we can see the value is correct. Then we look for the user secrets, Azure OpenAPI key does not exist. And then we search for Azure Search key. Make sure that the value is correct. So I'm just going to edit that and update the value. Apply, apply, confirm. Okay, the settings have been saved. If I go to overview and just copy this URL and hit in the browser, and this all looks good. Now, just refresh this page. Okay, so we have this HTTPS and also ending with slash. Click on connect. And meanwhile, we can see what's happening in the background. Okay, looks like it's all connected. List tool and just type a query. Error occurred invoking get results. So most likely something is missing in the configuration. We have to find out. Okay, so I looked into the application inside and it is saying that it's trying to connect to this URL which does not exist. And if I go to my Azure AI instance, the URL is this. If I copy that and here is my configuration and looks like this doesn't match. So that means this is not correct. So we need to update this. and just apply and save now. Okay, I have updated all the configs and I just did a stop and start, and now it's looking okay to me. So if I reconnect list tools and search for something, I can get some results back. Okay, so that means we can now use this URL when we are creating an agent. So that URL will go here. So we need to provide a label. So that could be Azure AI Search. And don't need to worry about authentication now. And that is our tool. And click on create tool. And the next thing, we will provide this instruction in a minute. So, and click on create agent on Azure AI Foundry. Okay, so the agent has been created. Now, next thing we need to do is provide instruction. And the best way to provide instruction is go back to DeepSeek and ask it. Okay, so we provided some basic context, what sorts of documents we have stored. And now we are saying that here is a signature of our tool. So go back to the tool and just copy these couple of lines. And all I will also provide probably we don't need to attach the files. We can say that these are the content. Okay, and we can go to MCP server and just copy this and paste it here. We should say that right in a paragraph. Okay, I think this is better. Just copy that and paste in the instructions. And I think we are good to go. It's updated. Okay, so the agent has been created. Click on the agent and click on open playground and write your first prompt. You don't need to worry about authentication. There we go. Okay, so this has, it doesn't show the status if it is active or not active. So let me repeat this one. It already says active, so we assuming that these are all active. And let's write one more prompt. And this time we say, please give me a list of active dental policies and sort them by premium amount and most expensive first. So, okay, so this one is $2,300, 83. This is 2372, 2273. It is doing sorting order by as well. Okay, so that looked like it's working as expected. Now, another thing I wanted to show is the thread. For example, if you want to debug it, we can have a look at the threads. So the first, when I typed, please give me a list of active dental policy, it came back with this result. But if you look at the step details, in this step, it made a call to tool, MCP tool, and in the query, it sent dental coverage, and in the filter, it says active is equals to true. So it's only returning where status is active is true. So we just typed a prompt, but it automatically converted this into a query. And then I said, please give me a list of active dental policies and sort them by premium amount and most expensive first. And it came back with this result. And if you look at the step, it made a tool call and it say the query was dental coverage. Filter is active is equal to true. And then order by premium amount sending order. So looks like it's all working now. And I think that's it for today. Maybe one more thing. Yeah, when we go to these indexes, you open your index and you can see all the fields we defined in that C# class. Everything is here. There is an option for create a demo app. Click on that, enable quotes. So because we don't have any image fields, so we can leave the thumbnail as is. For the title, we can pick the title, and for the description, we can pick the content. Click on next. And in sidebar, because we have that tags, which is an array, we can display this as a checkbox and click on create demo app. App is ready in a second. And now click on this search Azure Search.html page. So that will open a chat app for us. So just hit on this search icon and this will give us complete results. And you can see that the maternity had 33 record and this preventive care has 32 records. So if I click on vision, it sorts and filter those results. So that means the vision and the dental have some common results. And you can type your query here. So it is returning all the hospital related results, and there is a pagination as well. So that is just a quick small thing. So if you look at the content of that file, so that is written in JavaScript. It's writing in Bootstrap. It is using these search APIs, and here it is. So it's JavaScript code. I think that's it for today. Before we finish, let's quickly revise what we did today. Let me go back to search. Okay, so we created our data source, which is our storage blob, and then we created a function app. We created two functions in a function app. So the first one was document uploader, which uploaded all the documents in those storage accounts. And then we have this HTTP trigger, which we used to test all the different possible scenarios for the Azure search. Then we have this document service. We used a fake library and generated all the content, and then we uploaded all that into Azure Azure blobs. Then we created index and indexer, and then we performed the search. So we also created a class Azure AI Search document and define all the fields and the type of these fields. And then we created an indexer, and indexer has an index, and it rolled 100 result. And then we tested all this with Postman, and after Postman we exposed an MCP server, and for the MCP server we created a web app. We created a web app and defined a tool, so that tool connects to the API and performs the search. We tested this MCP tool with an MCP Inspector, and then we deployed into Azure, and then we created an agent. We created an agent in VS Code, and that displayed the result. And we also had a look at the thread. So that's it for today. I hope you enjoyed it. I just need one favor. Please like and subscribe, and see you again. Bye.